So now, in 3 dimensions, we can take what we know about vector and parametric equations of a line and really extend it. In order to give the vector or parametric equation of a line, you need a point and a direction. So now our point's going to be extended to 3 dimensions to include a z, so ZO, and our direction is going to be extended to include a 3rd dimension to that. So our point is XO, YO, ZO, and our direction is ABC. We still have t as a parameter. So parametric equation splits them all up into the y, the x, the y, the z. Vector equation just puts them together and has the point plus the parameter times the direction. So number 1, find a direction vector for a line through these 2 points. Well, to find a direction vector, I can backwards subtract to get the direction vector. And again, any multiple will work. I can multiply it by -1, I can multiply it by 2, I can multiply it by -2. Any multiple of this will work. If I do Q subtract P, I get this one. If I did P subtract Q, I would get that one. It doesn't matter which way you subtract as long as you're consistent. Perpendicular to the XY plane. Well, if we think about our 3 dimensions, X comes out to us and Y comes out that way. So the XY plane is lying flat on here. Z goes up and down through the XY plane. So perpendicular to the XY plane becomes the Z axis. The direction of the Z axis is no X, don't go left or right, or sorry, in or out, no Y, don't go left or right, and go up or down any number. So any number in for the C will work. You could use -1, +1, any positive, any negative number. So the number 2, find the vector and symmetric equation for the line through 5, -1, 7, and 2, 3, -1. So to give the vector equation, I need a point. Well, I have 2 of them. It doesn't matter which one I use. And I need a direction. I'm going to find the direction by backward subtracting. I'm going to take this one and subtract this one. So 5 minus 2 is 3. -1 minus 3 is -4. 7 minus -1 is 8. So I'm going to use that as my direction. So then my vector equation becomes, and again, it doesn't matter which point I pick. I'll pick this one. 5, -1, 7. You absolutely could put 2, 3, -1 there. Plus t times 3, -4, 8. Now, symmetric is something new. We didn't have symmetric in 2D, but now we're going to have it in 3D. Because if this is vector equation, if I think about this, I can write it in parametric equation. So my x would be 5 plus 3t. My y would be -1 minus 4t. And my z would be 7 plus 8t. All I did there was separate it out. There's something that's the same about these. They're all t. So in this case, t is going to be x minus 5 divided by 3. Bring the 5 over, divide by 3. For the y, t is going to be y plus 1 divided by -4. Bring the 1 over, add it, divide by -4. In the z, the t is going to be z minus 7 divided by 8. Now, you don't have to go through this each time. I just wanted to show you where the symmetric equation came from. And they're called symmetric because t is the same about all of them. That's the symmetry. So the symmetric equations becomes x minus 5 over 3 is the same as y plus 1 over -4 is the same as z minus 7 over t. And they're all, over 8. And they're all the same because of t. I wouldn't have to go through all this. It's x minus my point, so x minus 5 over a. Y minus -1 over b. And z minus 7 over 8. So that's how you give the symmetric equations. But now we're asked to give a vector equation for this. This doesn't quite look like symmetric, but because of the 2 equal sign, it is. For vector equation, I need to figure out a point, and I need to figure out my direction. Well, the x minus 3 over 2 looks normal. So I know the 3 is the x part of my point, and 2 is the a, or the x part of my direction. Y is the same as y minus 0 over 1. There's nothing being subtracted, and anything that's written not as a fraction is still a fraction. It's over 1. So 0 is the point of, or sorry, the y part of my point, and 1 is the y part of the direction, or the b. Now, I need z minus 0. I can see that on top, but they have a negative z there. Symmetric always starts with positive x, y, z. Well, that really comes from having a negative on the bottom. So negative z is the same as z subtract 0 divided by negative 1. So 0 is the z part of my point, and negative 1 is the c, or the z part of my direction. So now my vector equation becomes x, y, z, or some people just call that r, it's the same thing, is 3, 0, 0 plus t times 2, 1, negative 1. So symmetric, sometimes you have to think about the information that you're not seeing in order to get it and use it.